In this video, we will focus on force vector. Now, in this course, you might notice that we deal a lot with vector operation. The reality is, in 3D space, for many type of problems, it's much easier to solve any problem with using vector operation compared to scalar operation. And in vector operation, for example, to calculate moment, you can use cross product. We do need the force in a vector form. Sometimes the problem or the question have the force in a magnitude. Hence, we need to know how to convert that force in terms of magnitude, in terms of force, in terms of Cartesian vector form. And hence, this is the focus of this video. Now, there are three possible scenario or three different type of information that you might be given in any particular problem. And sometimes it's a combination of these three type of information that you need to be able to use and utilize to get your force in terms of vector form, right? The first one might be in terms of projected angles, right? So we'll list this first before we go into more detail. Second, it is coordinate direction angles, right? And finally, it is basically if you can find the coordinates, right? So those are the three type of information that may be given on top of the magnitude of the force, so that you can utilize this information to get what is the vector of that force, right? So what is a projected angles? So imagine if we have, let's say, this is x-axis, y-axis, and z-axis, right? For example, this is x, y, z, right? And if we have something like something like this, right? And then we have a force from the origin to this point here, for example, F, right? So if we have this, right? So this is what we call, or we can refer to as projected angles, right? So the information may be given in the sense of this angle is being given to be something, and for example, this angle is given as something, right? So you need to be able to use the information given. For example, in this case, we might need to use the two triangles, right? So one triangle is here, right, where this is the 90 degrees, and another triangle is here, where this is 90 degrees, right? So using that two triangles, we can find the component x component, y component, and z component, and then we can describe the force in terms of Cartesian vector form, right? So the detail of this is already in the lecture video. So hopefully this is just to highlight what you need to know in preparation for the exam or in the real world of engineering, right? So this is one type of information that may be given, and you need to know how to do this, right? So that's number one. Number two, coordinate direction angles. So for example, you have x-axis, y-axis, and z-axis. So if you have a force somewhere here, and then what is given is this angle, for example, the angle with respect to x, the angle with respect to y, and the angle with respect to z. This is basically alpha, beta, and gamma, right? So you should be able to use this to get the vector of the force as well, right? So that's the second type of information that you might be given. So my daughter is happy back then. Anyway, so the third one is coordinate. Sometimes you do not have any angle given or any direct angle given, but for example, you have, let's say we still draw the axis, but you have one point here and then one point here where you know the force is in that direction, right? So basically what you can have is that what is the coordinate here, for example, yeah, I'll just leave it blank here. something, something, and something, and then what is the coordinate here? Something, something, and something, right? So from the coordinate, you can find what is position vector, and then the magnitude of that, and unit vector of the line, and then you can describe what is the force in terms of Cartesian vector form, right? So this is the three different type of information that may be given, and sometimes it is combined in one question, right? For example, in this question you have three different forces. One forces is being given with this information that you have to use the two triangles. One force is given in terms of alpha, beta, and gamma. One force, you know the coordinate. So you need to know how to utilize these three different information, right? Now, of course, normally the coordinate is not directly given. It is given in terms of some distances, etc. And you need to be able to use all those distances to determine the coordinate of the 2 points. Now, that is in terms of the question, right? How to get information from the question to the force in terms of vector form before you can actually use in your calculation. So now, normally in the final answer, if the question actually asks for force, for example, resultant force, right? Or one of the force that makes the whole system equilibrium, for example, right? So the final answer may be in terms of, for example, vector, which means that embedded in this is already the value of the force, the magnitude, as well as the direction, right? Or the question may ask what is the magnitude as well as what is the coordinate direction angle, right? So this is also sometimes the question asked of the force in just simply Cartesian vector form, or what is the magnitude and what is the direction, or what is the coordinate direction angle, right? So you should know already also how to get from this vector, because normally when you calculate in terms of vector, you will get the answer in terms of vector, be it resultant force, be it force required, and then how to get the magnitude and how to get the alpha, beta, and gamma. So make sure you know how to obtain all of this, and if you know, then inshallah for this part you are okay. For if you are not sure for anything, you can ask either in the class or in the comment section below. Straight away, do not forget to ask and identify which point that you need to, resolve if you are weak in any of this, right? So this is about force vector. In the next video, inshallah, we will talk about direction of moment, because some of the students, I noticed that in the quiz they are confused about that, so I'll make a video specific on that, inshallah. Until then, all the best.